Hello, this is Mr. B, your math analyst. And today, we are going to start applying the concepts that we learned from trigonometry, that means right and non-right triangles, to daily situations. So I hope that this lesson is useful for you. Don't forget to subscribe, to give a like, and let's start with this. So today, our first problem, we're going to solve three problems. Our first problem is about bearings. So I'm just going to read from the statement from my computer. It says, a ship leaves a port and travels 40 kilometers on a bearing of 40 degrees. After changing direction, it continues to travel another 70 kilometers on a bearing of 120 degrees. How far is the ship from the port? Okay, so basically, every time that we are talking about bearings, the key is that we start in every mention that we have of the word bearing, we are going to make a coordinate grid or a Cartesian plane, okay, as the one that I have here. So notice that from the origin, it says that the ship travels on a bearing of 40 degrees for 40 kilometers, okay? So knowing the concept of bearing, if you don't know what a bearing is, I suggest you to watch the short video that I recorded about bearings, okay? You are going to find the links of that video below, okay? So all those videos that are a complement to our lessons, you're going to find the links in the comments, okay? So as I said, we have the ship starting from this point, which is the origin, and it says that it travels on a bearing. So this is a bearing. Remember that the bearings start from the north. So 40 degrees, and it says 40 kilometers. So 40 degrees, 40 kilometers. Okay? Now, notice that if we go back to the statement here, it says that after when it arrives to that place, after changing direction, it continues to travel 70 kilometers on a bearing of 120 degrees. And notice that again, they are mentioning the word bearing. So that means that I need to construct a coordinate grid. Every time they mention the word bearing, I'm going to construct a coordinate grid. Okay? So here I have my second coordinate grid. Okay, let me make the horizontal line here. So this is the second position of the ship. Okay, let me see. There you go. Let me try to make it more horizontal. Here we have it. Perfect. So notice that that is the second place where the ship is now. Okay, what we are gonna do? Basically, we are gonna draw again the direction now the ship is going to travel. Okay, so it says that is 120 degrees the bearing. Okay, and let's go back 70 kilometers. Okay, so basically 120 degrees possibly is here, starting from the north, and 70 kilometers. I don't know where that is, possibly is here. Okay, so there you go. And now it says, so again, this is 70 degrees. And now it says, find the measure or the distance from the current position to the initial position, how far the ship is. Okay, so basically they are asking us this position that is here. Okay, okay, great. And what I'm going to do before starting solving this is I'm going to label each of the vertices. So we already know that this one is the vertex O, and this is the vertex A for me. You can label as you wish, with the letter that you want. Okay, and the other one is going to be the vertex B. And here we know that this is 70 kilometers. So something important, okay, let me make this shorter. Okay, something important. I don't know if you remember this, but I mentioned it when I was teaching you the law of cosines, I was mentioning the importance of identifying when to use sine rule, when to use cosine rule. Those are the only two options. Why? Because this is a non-right triangle. And I don't know if you remember, but here we have the sandwich. So bread, and the angle within, okay? The two bread. So in other words, when I have two sides and the angle between those two sides, that is a situation, or that is an indicator that I need to use the law of cosines. Now, notice that here I don't have this angle. I need to find it out, okay? And something important here, first we need to understand that this vertical line is parallel to, let me extend this one, to this vertical line. Remember the lesson of two parallel lines and a transversal line between them. So this is that situation. We have two parallel lines. This one, this vertical with this vertical, they are parallel. And if they are parallel, that means, I'm going to remove this horizontal line from here. Notice that they are making the letter C. And what I know is that two angles that are making the letter C, they sum up to 180 degrees. So if that is the case, that means that this angle here is 140 degrees. Why? Because 140 plus 40 is 180. And now I'm able to find this angle that is here. How? Well, I know that 140 plus 70 plus whatever this angle is going to be 360 degrees. So basically, to find this angle, I'm going to call, so that angle, that angle is the angle OAB is going to be 360 minus 70 minus 140. And that is 360 minus 70 minus 140, that is 150 degrees. So in other words, this angle here is 150 degrees. Okay, I have now everything set up to apply the cosine rule. Okay, so remember that the cosine rule starts with the letter you want to find. So OB to the second power equals 40 degrees plus 70 degrees minus 2 times 40 plus 70 cosine of 150. And if you don't know how to use the cosine rule, my suggestion, dear people, is go back to my video about how to use the cosine and the sine rule. Okay, so well, I already have the cosine rule set up, and basically what I need to do is I just need to input this in my calculator. I'm going to show you how this looks like. Let me move this a little bit above here. And basically what I'm going to pass directly is this square that is here. I'm going to pass it to the other side as a square root. Okay, so square root of 40 degrees to the second power, no, not 40 degrees, 40 to the second power plus 70 to the second power minus 2 times 40 times 70 cosine of 150. Please check that your calculator is in degrees. Mine is. So I just press enter and the measure is 106.53. Okay, I'm going to round to 3 significant figures, so that means 107. Okay, so 107, and this is kilometers. Okay, so here you have the situation. As I mentioned, it is a case of cosine rule. I identified it because I got the sandwich in the problem. We applied the concept of bearings. Okay, let's go to the next problem. Okay, here we have it. Okay, this is a classic problem or a classic scenario of the IB exams. Okay, and it says that in the figure, the angle of elevation of the top A of a building OA, so basically the building is OA, the top of the building is A, the point A, from a point B is 35 degrees. C is a point on BO. such that AC is 96 meters and BC is 64 meters. And there are three questions they are asking us. First, find the size of the angle BAC. Okay, what else? Find the size of the angle OCA. Find the height of the building OA. So let's go step by step. Let's go with every question. Okay, so it says, first it says find the angle BAC. So here, notice that I already labeled all the information that is given. Okay, and basically notice the following. They are asking me for this angle BAC, this one that is here. Okay, let me confirm. Yes, angle BAC. Okay, so this is the angle they want to find. Okay, and notice that in this triangle that I have here, which is BAC, is a non-right triangle. That means that I only have two options, either law of sines or law of cosines. But since one of the angles is given and its opposite side, and basically I have the opposite side of the angle that is requested, that is an indicator for me to apply the law of sines. Okay, so with law of sines, I'm gonna write here. Let me see if I can move this and make it a little bit smaller. Okay, so I can use more space. Okay, so I'm gonna start by setting the law of sines. Okay, so since I want to find the the angle BAC, I'm gonna start with sine of BAC. Sine of BAC is 264 as sine of 35 is 296. Okay, and basically I'm gonna solve this for the angle BAC equals the inverse of the sine of 64 times sine of 35 divided by 96. Okay, if you don't know how I solved this for the variable that I did, or in the way that I did, I suggest you to go back to the videos that I recorded about law of sines, okay? Which is very explicit and also in a normal pace, in a pace that is understandable, okay? So here, I'm gonna put the calculator here, and basically what I'm gonna input is what I have there. So inverse of sine, and the cool part of this calculators that we have here, okay, I'm using the TI-84 plus CET, is that I can work the fraction, notice that, with this symbol, alpha, and this green icon here. So alpha, this x variable button, I can write it as a fraction. So 64, you see, here, 64 sine of 35 divided by 96. 96. There you go. Okay, so the angle is 22.5. So sorry, let me erase. BAC is 22.5 degrees. Okay, so I already found the angle BAC, 22.5 degrees. Okay, let's go to so this was question A. Let's go to question B. Question B says, find the size of the angle OCA. Okay, let's go to the drawing. So the angle OCA, basically I'm gonna highlight it with another color. Basically they are asking me for this angle, okay? And the key is, so I need to work, you notice, if I see the other triangle, ABC, this one, ABC, notice that this angle that is here, okay, is supplementary with the angle that is requested. So in other words, if I find this angle, and after finding it, I subtract it from 180 degrees, I'm gonna find the angle ACO. Okay, so let's do that. Okay, notice that basically the idea is that 35 plus 22.5 plus this angle is going to be 180 degrees. Okay, so what I'm going to do is to find the angle BCA. Let me write the notation of angle BCA. What I'm going to do is I'm going to subtract 180 minus 22.5 minus 35. Okay, so 180 minus 22.5 minus 35, this is 122.5. So as I mentioned this is 122.5, and it is the supplementary angle of the angle that is requested, which is ACO. So to find ACO, what I need to do is just 180 minus 122.5. Okay, 180 minus, let me put it here, 180 minus 122 minus 122.5. That is 57.5 degrees. Okay, so let me add a page because we are going to need extra space. Okay, so I already answered question A and B. Let's go to the last question of this problem. Okay, now it says find the height of the building OA. Okay, and basically, if you already arrived to this place, it's going to be easier because it's a right triangle. Notice that the height of the building is given by AO, and AO is a side that belongs to the right triangle. Okay, I already know this angle, 57.5. Okay, so what I'm going to do, notice that 96 is given, and 96 is the hypotenuse of this triangle. So what I'm going to do is, since this is the opposite side, I'm going to work with sine. Okay, so let's do it. Sine of the angle 57.5 equals the opposite side, which is AO, divided by the hypotenuse, which is 96. Okay, and now solving for AO, okay, this that is here. So 96 times sine of 57.5, that is 80 point, well, if we round to three significant figures, it's actually 81. Okay, I'm gonna show you that because sometimes that is tricky for the students. Okay, so notice the answer. The answer is 80.96. If I round to three significant figures, I need to round this 9. But since the 6 is greater than 5, sorry, I need to round up. Okay, and round up means 10. So in other words, it's not going to be 80.9, but 81. Okay, 81.0, and that is meters. Okay, so that's the answer of the third question. Notice that here we are using the concepts of angle of elevation and angle of elevation, not angle of depression. Okay, let's go to the final problem that we're gonna solve today. Okay, so our final problem is this one. It says a 3D diagram below shows the air traffic control tower, CD. Okay, so basically what you need to understand is that this CD is the control tower. Okay, something important, this triangle that we have here, ACB, is on ground level, as well as this runway 1 and runway 2. So in other words, those here we have, as the problem mentions, this is a 3D diagram. So in other words, we have a part of the diagram which is on ground level, and the other part is on the sky level. Okay, or with some altitude. Okay, so that is something important to understand. Okay, let's continue reading. It says, and the starting point of two runways. The start of runway 1 is at point A, And the start of runway 2 is at point B. Points A, B, and C are on horizontal ground, and the control tower is vertical. So here we have the definition that they are in different altitudes. Okay, now they tell us that AB equals 230 meters, AC equals 340 meters, the angle of elevation of D from point A is 12 degrees, and the angle CAB is 108 degrees. Okay, there are different questions. So let's start by finding the distance BC. Okay, so here I already made the drawing, as you can see here. Okay, and the first question says find the distance BAC. Notice something. Here we have the sandwich. So immediately I know that I need to apply cosine rule. Okay, so I'm going to do it. Let me make this smaller. Let me erase here. Okay, because I need more space. There you go. Okay, so BC to the second power. Remember that I always, when I'm working with cosine rule, I always start with what I'm looking for. Okay, so in this case, the variable I'm trying to find is BC. So I'm going to start from it. Okay, so BC equals the other two sides to the second power. Okay, minus 2 times 340 times 230 cosine of 108. Okay. Okay. So basically, I'm going to input this in my calculator. If you don't know how to do it, here you have what I'm going to input. Okay. So remember that always I pass this square to the other side. So it's going to be the square root. Okay. And here. Okay. So it's 340 to the second power plus 230 to the second power minus 2 times 340 plus 230 cosine of 108. Okay, so when we press enter, the answer is 465.65, rounded to 3 significant figures, 466. Okay, and this is meters. Okay, so this was question A. Perfect. Let's continue. Question B. Find the height of the control desk above the ground. Okay. So this is the control desk, and basically it makes 90 degrees with the horizontal. Okay, and they are asking us to find CD. Notice something important here. What we are observing is a right triangle. Okay, and from that right triangle we have the angle, and we have the adjacent side to that angle. Okay, and notice that what the question is the opposite side. Okay, so basically what we're going to do is we're going to work with tangent. Okay, remember that the trigonometric ratios are just applicable to right triangles. Okay, so the tangent of 12 equals the opposite side, which is CD, divided by the adjacent side. So basically we need just to solve this for CD, as you can see here. And I'm going to input this in my calculator. Just be careful to have your calculators in degrees. Okay, 340 tangent of 12, that gives me 72.3 meters. Okay, so that is the height of the control desk. Okay, so we know that this is 72.3. Very good. Let's continue to the next question. The angle of depression of the start of runway 2 from the control desk. Angle of depression. Okay, so basically let's zoom a little bit here. I'm gonna change the color to label what they are asking me, and they are asking me, it says the angle of depression. Remember something, now we have two perspectives. Okay, and I'm gonna take this triangle. What I'm going to do is I'm going to take this triangle apart so it is more understandable. Okay, but basically you need to understand that here we already know something. Let me write that down here. We know that this is 466. Okay, meters, of course. Okay, and we have the height of the control desk. So basically, it's still being a right triangle. So with tangent, we can find this angle, and you're gonna realize. So you're gonna wonder why we're gonna find this angle if this is not the angle of depression. Well, let me take this triangle apart so you can realize what is happening. Okay, so I'm gonna zoom out a little bit. Here we have it. So as I said, what I'm gonna do is I'm going to draw this triangle apart. So we have it here. Okay, this is the triangle. So here we have the point of runway 2. Okay, and here we have a CD. Okay, let me just check. CD. And we know that this is 466. And this is the altitude is 72.3. Okay. And basically, again, let's understand what they are asking us. So from this triangle that I just drew, what they are asking us is actually this angle. This is the, hold on. This is the angle of depression. Okay, this is what they are asking us. But the easiest way, we need to understand something. This green line that we have here is the horizontal line. And it is parallel to this horizontal line that we have here. So in other words, we have a case of two horizontal lines that are parallel, of course, and they are cut by a transversal line. So in other words, this angle of depression they are asking us is exactly the same angle we have here. Why? Because notice that here we have the Z that we mentioned it in our video of parallel lines and a transversal. Okay, and something that we mentioned is that this alternate interior angles, they have the same measure. So in other words, if I find this, I'm going to find this other one that is here. Perfect. So knowing that, now that we define why we are going to do what we're going to do, let's apply it. Okay, so we know that I'm going to label this angle DRC. Okay, so the angle, the tangent of the angle DRC equals, and now we have the opposite side over the adjacent side, 72.3 divided by 466. Okay, so the RC is the inverse of the tangent of 72.3 divided by 466. Okay, so that is 72.3 divided by 466. That is 8.82 degrees. Okay, so that is that angle. Probably my drawing is not on scale. That doesn't look like 8.82 degrees, but that is what it is. Okay, let's go to the final question. Okay, and possibly is the more challenging question. Okay, so it says the airport management is planting more grass to make the airport feel more welcoming to the passengers. The triangle ABC, the one that you can see there in the drawing, is to be seeded with grass. A bag of grass seed weighing 10 kilograms covers 1,156 square meters and costs 320 Norwegian krone. Norwegian, I think that's the way we read it. Okay, how much will it cost to seed the triangular area ABC? Give your answer to the nearest 100 Norwegian krones. Okay, so notice something here. What we need to find, they're talking about area. So the first thing that we need to determine is the area of the area that is going to be seeded. That is what we need to determine first. Once we have determined that, what we're going to do is we're going to work with unit of conversion, okay? So we know that 320 NOKs are able to plant 1,156 square meters. That is what we know. And that is what we're going to use, okay? So let's write that down, which is, I think, it's going to be clear. Okay, so as I said, the information that is given is that with 320 NOKs, I'm able to plant 1,156 square meters. Based on that, what they want to know is how much will it cost. But first, we need to find the area, okay? And, well, we already learned how to find the area when we have the sandwich, and here we have the sandwich. So I'm going to find the area of that triangle, okay? Basically, the formula is 1/2, okay, and the first side, which is, I think that we can do it here. 340, the other side is 230. Hold on. Here, 340. 230, okay, and the angle is 108. So remember that the formula is 1/2 340 times 230. So the two sides that are bounding, no, that are delimiting the angle, sine of 108. For those that do not know this formula, well, there's also a video that I recorded about finding the area of non-right triangle. So go there. The links are on the description. Okay, so just go, just scroll down. Okay. Okay. So now that we have this formula, let's input this in our calculator. So 0.5 times 340 times 230. Sine of 108. Okay, and basically the area that we found out is 37,000. Here I have it. 37,186. 37,186.31. And something important that you need to know is that here I'm writing until, or rounded to 2 decimal places. But in reality, in my calculator, I'm going to use all the decimals, okay? And now, let's see how we're going to use this unit converter that we have here with this area. Okay, so basically, I'm going to take the area, and I'm going to multiply it by the unit converter. Okay, let me erase something here. So it's, remember that this is square meters because it's area. And with the unit converter, if I put the area in the denominator, the square meters are going to be canceled, okay? And the NOKs are going to be the resulting unit, okay? So basically what I need to do is multiply 37,000 times 320 divided by 1,156. Okay, now that we know this, that's what I'm going to put in my calculator. So notice that here, I'm just going to press times, and the calculator is taking all this answer, multiplying by 320, and then divided by 1,156. Okay, and this is what is needed. So we need 10,293.79 NOKs. Now, if the answer needs to be rounded to 3 significant figures, that means that I need to round it to this place. Okay, so I'm going to round it up because the next digit is greater than 5. Okay, so it's 10,300 NOKs rounded to 3 significant figures. So this is the budget that is needed to make that that area to be more welcoming. Okay, so guys, this is basically some different applications that we did to the concepts that we learned from trigonometry. Please do not forget to subscribe. Do not forget to share this to someone that is dealing with these concepts, and give a like. Okay, remember that if you support me, I can continue making these videos. So again, my purpose is to help you. If you have any questions, please write on the comments. Well, with this, we finish. See you in the next video. Bye.